Okay, 6.4 for this year. Let's take a look at the conjugate. So big underline in red, the word conjugate. We're going to use that. So the conjugate of A plus B is A minus B. And the conjugate of A minus B is therefore A plus B. The conjugate of 1 plus sine x is 1 minus sine x. And the conjugate of 1 minus sine x is 1 plus sine x. Obviously, it works with cosine as well. Take a look at the notes. So now I'm going to do one of the 4 examples from down below. Let's put a 1 minus cos x on the bottom. And I'm just going to circle the top. I don't care what's on the top right now. The purpose of this example so far is only introduce a denominator of 1 minus cos and what you can do with it if you multiply by the conjugate. So the conjugate of 1 minus cosine x is 1 plus cosine x. And if I multiply the top and bottom by the conjugate, I will be able to simplify in the following way. So first of all, I'm going to put brackets around all of my factors. Now, we actually saw the conjugate last year in radical functions. If we ever had square roots on the denominator, we would multiply by the conjugate. So if this looks a little bit familiar, that's where it's from. Now I need to choose something on the top, and I'm going to write it out in red because it's going to help us follow through the next steps. So I have to shrink this down a tad so I can do a step off to the right. So on the top in red, I'm going to skip a line. I rarely do, but we have sine x. And beside it on the top, we have 1 plus cos x. Excuse me, back a second. I'm really just going to put a box around this and call this what it is. The conjugate. As we have been discussing. Conjugate. Excuse me. Conjugate. J. Conjugate. So, back to the fraction on the denominator. We have 1 minus cos x and 1 plus cos x. And that looks like an interesting looking thing, and we should do that off to the right. So we have 1 plus cos x, and we have 1 minus cos x. And if I multiply the first by the first, and the first by the last, and the second by the this, and the FOIL, first, insides, outsides, last. 1 times 1 is 1. 1 times negative cos is negative cos x, obviously. Positive cos x times 1 is positive cos x. And positive cos times negative cos is negative cos squared x. And in red pen, I can cross off those middle terms. And it simplifies to be 1 minus cos squared x, which is very useful because that, from the second sheet in formulas, the useful algebraic manipulations of the sine squared plus cos squared equals 1 Pythagorean identity is simply just sine squared x. So whenever I work off to the right, I have to bring it back to the left. Now I could write it way down here, but I understand what I did. So again, on the top, I'm going to write sine x in red, so I remember that's the made up thing, and the part of the conjugate that I wanted, and then it's over the sine squared x that we just figured out, sine squared x, which means now look at this. I've got a sine x on the top, which I can cross off, and I'm just going to cross off the squared from the bottom. And I can simplify that, and I get 1 plus cos x over sine x. I'm going to circle that answer. So where have we come from? Well, we came from the question that we began with after we introduced the conjugate in algebra and with trig functions. Then we introduced the question the conjugate, and then we did the method, the conjugate, multiplying the top and bottom by the conjugate of the denominator, conjugate. Then we decided to take that denominator and FOIL it off to the right, and then we simplified it using the Pythagorean identity to sine squared x, and then we substituted that back into the denominator. Then we simplified, dividing the top and bottom by sine x, crossing off the sine x from the top and the squared from the bottom, and getting this interesting new function, 1 plus cos x over sine x. So notice in big blue, the question that we started with, sine x over 1 minus cos x. We multiplied by the conjugate, and we did a whole bunch of other stuff to get it to say 1 plus cos x over sine x. Well, now we're going to look at that exact same identity. So in big blue at the beginning is going to be a variation of the proof. It's actually not, so good thing sometimes the notes are followed, and sometimes I accidentally do a very similar question, but I digress. And the right-hand side is similar to the blue down below. So now let's take a look at that proof like that. Let's use the conjugate. You know what? I'll do that same question. So we'll do that question using the conjugate, a different conjugate than this time, but obviously for reasons. And then we'll go through each of the individual steps. But just a reminder, in big blue, off to the right, when we do the conjugate, the steps are always FOIL first, outsides, insides, lasts, but we don't have to do the two middle steps. Then we use the Pythagorean identity. Then we simplify, which is a grade 8 or 9 method, so we're not going to write it down. And then hopefully it's the right-hand side. So one more time. Conjugate, F and L, Pythag, simplify. F and L. Pythag, simplify. So now let's go through that proof. Okay, let's look at the proof at the bottom of the page. Still same page. Sine x over 1 plus cos x. Sine x over 1 plus cos x equals 1 minus cos x over sine x. And lots of the times you get here from different problems in the future, and you have to be able to recognize at this point it's a good idea to use the Pythagorean identity, the conjugate, to eventually F and L, distribute and cancel, and then use the Pythagorean identity and then simplify. So we're going to do that right now. Now notice in the notes I was working on the left-hand side. You can work on either side. Usually I work on the right-hand side because I have more room. You know what? I'm going to do that. So you have the notes to look through, and you can watch this video, copy down these notes if you'd like another example. So make your T. Remember, we're not allowed to do algebra back and forth. Now I have room on the right-hand side. So why not just do it right there? And I'm going to multiply by the conjugate, and I'm going to do it in red so we can tell the difference between what the question initially was, that I'm going to highlight in red, compared to what we're going to have after. So I'm going to multiply by the conjugate. And I'm going to multiply the top this time, because it really doesn't matter. You can times the top and bottom by the denominator conjugate or the numerator conjugate. And I actually just ran into this problem right now, but I'm going to go with it. So I'm going to multiply the top and bottom by the conjugate of the numerator, 1 plus cos x, the top and the bottom. And I'm going to put brackets everywhere. Brackets, 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 brackets. And then I'm going to distribute the top. And I already went through how we can multiply out a 1 plus cos and a 1 minus cos. So I'm going to go through those steps much quicker. So remember, I am working with a fraction. I'm just going to start with that fraction on the right-hand side. And remember, when you can get rid of a denominator, let's just not get rid of it, but when you can get it out of the way, let's just put it down there. Sine x, open bracket, 1 plus cos x. And again, do we FOIL that out or not, or distribute it out or not? Well, why would we? Because if we did that, we'd have to refactor. The only reason why we're FOILing or distributing out the top is because we can possibly combine like terms, which we've shown in the previous part of this video. So 1 times 1 is 1. 1 times cos x is positive cos x. Negative cos x times 1 is negative cos x. And negative cos x times cos x is negative cos squared x. And again, I'm going to cross out in red, just like I did in the last example. And I'm going to simplify. Again, I'm going to start off with my fraction. I'm going to skip an extra line just for clarity. And on the top, I have 1 minus cos squared x. And at the bottom of whatever it is. And lots of times, I don't like to keep writing the bottom. So I just write dot, dot, dot. And that means that I have to carry down the bottom later. So let's work on the top. Well, that looks like the Pythagorean identity. So I can substitute the Pythagorean identity in for it. So the top, I'm going to circle in red. I know from my identity sheet is sine squared. So I can substitute sine squared in for the top. Sine squared x. And now I can say over, and now I can write what those dots were, so I don't have to waste ink and whichever. Easier to follow, all sorts of reasons. So now I'm working on the denominator. Where did that one I get lost from? Well, it was way up here, and I got a whole line of not having to write it. So it says sine x, open bracket, 1 plus cos x. Clean that cos x up a little bit. Cos x. And now I have a sine on the bottom and a sine squared on the top, so I can cross off the sine, I can cross off the squared from the top, and then I can say Q, E, D. And I'll circle the right-hand side, and that is exactly equal to the left-hand side. If you want to simplify it further and rewrite more steps, if your teacher really requires you to show all that extra stuff, usually they're okay with just simple little crosses off. So, again, the conjugate methods are conj, F, L, Pythag, simplify.